Hello, this is Team 8 of Kim Hui-won, Lee Nam-hoon, Cho Ah-la, and Justin Chan presenting on the Haidar Aliyev Center. This is our Week 10 presentation. The basic idea underlying the design of the Haidar Aliyev Center is that the main building develops its form from the plaza in front of it. Architecturally, the plaza is divided into strips running from east to west as shown in the highlighted areas across the graphs. These strips start on the ground as a walking surface, then wrap upwards around the main building to create the well-known free-flowing 3D shape that we've studied. In addition, this geometry of the building envelope is reflected in the interior wall of the building as well. This picture shows the curves of the envelope on the interior roof in a hallway. This picture shows the curves of the envelope in the auditorium. The entire building can be subdivided into two areas. Section 1, the museum side, and Section 2, the auditorium side. The auditorium area contains the auditorium itself, a library, and a multi-purpose hall. Up until now, we have studied about the GFR panel material and the steel space frame structure used for the free form of the building. Last week, we took a look inside the building and looked at the construction of the auditorium. The auditorium had to carry out two missions to play its part of the building. First, we saw how it enabled concerts next to quiet interior spaces. Using the sound isolation noise control method known as box-in-box construction. Inside the building, they added concrete walls as thick as 60 centimeters and added 1,200 square meters layers of rock wool insulation. Inside the new box, architects wrapped the floor walls and ceiling with more than 280 interlocking oak panels. Next, they had to support various activities including speech, orchestra, and opera. Because each of those different kinds of performances have different acoustical needs, the introduction of coupled spaces was put into the project. Designing a coupled space hidden above the ceiling, 4 meters of additional room is used to modulate the reverb that is created when sound is made on stage of the auditorium. Today, we will introduce some interesting things about the library. On the north side of the building, we can find the library with its own entrance. This is used for daylight control. Let's take a look at the cross-section of the floor plan through the library. This part of the building is 8 floors tall, containing multiple archive floors stacked above the library. The floors are connected by ramps that create a continuous path of circulation. In addition, the conference hall is connected to the library by a bridge that creates the perfect inclination for the auditorium seating. The screen is a facade on the north side of the building where the library is located. Because the library is located adjacent to the side surrounded by glass windows, it uses natural light during the day and self-lighting at night to light the zones. Thus, the Haidar Aliyev Center uses two methods for lighting. One is the curtain wall system for daylight, and the other is the wall-fixed LED luminaires. From today on, we'll present the natural lighting method of the building around the glass curtain walling located in the library. We will be looking at the system structure and unit analysis of the glass curtain wall, and proceed with the order of assembly. Beginning with the unit analysis, the curtain wall system was adopted where it was not covered by panels to illustrate the continuous and sleek facade while ensuring a clear view for the natural lighting to pass through. It literally takes the form of a curtain-like window. On the main concrete structure that consists of concrete columns and beams in a grid. Horizontal and vertical spanning members of a frame are connected. These horizontal and vertical members are called transoms and mullions. The glass is then inserted into the frames, and the transoms and mullions play an important role in transferring the load of the glass facade to the main concrete structure that is attached to. In this building, the glazed curtain wall is the window to the cultural center. The glass curtain walling is a building envelope that is intended to only support its own weight and withstand the effects of environmental forces such as wind or earthquakes. As a result, it is not intended to assist the structural integrity of the building. The Haydar Aliyev Center has to accommodate the horizontal interstory drifts due to wind and seismic impact. Owing to quality and interstory drift considerations, it was decided to use a unitized fixed glazing curtain wall system, with adapter frames bonded to the inside by means of structural silicone adhesive. There are two main types of curtain walling construction, stick and unitized. The differences depend on the method by which the components are assembled. In the stick curtain wall construction, the components are assembled piece by piece on the site. On the other hand, in the unitized curtain wall system, the parts are already assembled in the factory. The components are installed and brought as a single unit from the factory to the site. The complete assembly of the units in the factory brings some benefits. Improved quality control, quicker installation that requires less manpower on site, and also it can be installed from the interior of the building, which is ideal for high building sites. Unitized curtain walling can be installed either from the interior of the building using a beam on the floor above, or from the outside using a crane. The glazing units with these frames are attached to the split mullions and split transoms of the facade units by screws concealed by metal caps. Each unit or facade panel is suspended from its top. This support provides sufficient flexibility to accommodate tolerances, thermal and structural movements, and especially the critical in-plane earthquake shear effects. This is the end of the presentation. Thank you.